Welcome to the NPTEL online course on fractals and multifractals. In the last lecture, we have discussed the parameter estimation of fractal interpolation function. The parameters of iterated function system is estimated in the last lectures. There are two parameters mainly influence on the data in the y directions. One is the scaling factor alpha I, another one is the function qi of x. Based on the function q, the fractal is defined as linear interpolation function, quadratic interpolation function, alpha fractal interpolation function. After that, we have seen the different type of alpha I, that means the scale vector, it generates the different images, that means different graphs. Now in this lecture we are going to discuss in detail about the vertical scaling factor. So this lecture we are going to discuss the influence of vertical scaling factor of fractal interpolation function using different iterated function system. Let me recall here, if the data points xi and yi is given, these data points are taken from r power 2 such that the xi's are less than the xi plus 1, that means xi's are increasing for all I. Now there are n, here we are taking, there are n minus 1, not here, not n minus 1, there are n number of data we can take, sorry, this is n minus 1, this is n minus 1, since we are taking I from n. So there are n number of data, therefore n minus 1 number of mapping. For constructing fractal interpolation function for this data, first let us constructed the two function, one control in the vertical direction, another one control in the horizontal direction. For the horizontal direction we can use Li in the x direction, in the vertical direction for we use Fi. This Li is mapping from I to I, where I is the closed interval x1 comma xn, where Ia is the xi comma I plus xi plus 1 for all I belongs to n minus 1. There are, if we have the n number of data, then we will get n minus 1 number of interval. So for each interval we are defining Li map. Similarly, each interval we are defining Fi map corresponding with the Li map. Then by using this Li and Fi, we can construct the Wi. Here we defined Wi from the x to r, we define where x is a I cross closed interval a comma b, where a is the lesser value minimum among all the y. We need to find the minimum of all the y, and a must be less than the minimum of all y, and find the maximum of all the y values, and b must be the greater than value of yi values, maximum of y values. Now Fi is a contraction with respect to the second variable. F is defined from x to r, F is contraction with respect to the second variable. By using the L and F, one can define Wi from x cross closed interval a comma b, that means R2 not closed, I cross closed interval a comma b2, maybe I will write it again. Wi defined from I cross a comma b to I cross closed interval a comma b. Previously I written R, but we can take a comma b itself. Then by taking the union of all this mapping, the union of all the Wi's, we can define the HB mapping F. Then we obtained that this HB mapping has the fixed point. That fixed point is a graph of a continuous function which passing through the given set of data point f of xi equal to yi, where f is the attractor of this HB mapping with respect to this iterated function system. Then here Li and Fi, while constructing Li Fi, both satisfying endpoint condition that Li of x1 equal to xi and Li of xn equal to xi plus 1 and Fi of x1 comma y1 equal to yi and Fi of xn and yn equal to yi plus 1. Like that we defined this Li and Fi. Therefore, this Wi satisfying the endpoint condition x1 comma y1 will map to the xi and Wi of xn and yn will map to the this xi and yi map to the xi yi, and here it will map to the xi plus 1 yi plus 1. Okay, fine. Now we discuss the special form of iterated function system. Li of x we have taken aix plus bi, and Fi of x comma y we have taken alpha time y plus qi of x, alpha I time qi of x. More precisely, we have discussed based on this qi, this nature of the fractal interpolation will vary. Now in this lecture we are going to discuss qi of x equal to aix bi ai bi used cix plus di, particularly the linear case. So by using this endpoint condition, we can obtain the parameter a, b, c, d. Then if we have this parameter, then we can get the iterated function system corresponding to this parameter. Then this iterated function system will generate the fractal interpolation function. Now we are going to discuss what is the influence of this scaling factor in the fractal interpolation function, how it's changed the pattern and structure of the fractal interpolation function. Fine. Let us consider the data point given here. There are 6 data points are given here. Then the choice of qi is a linear polynomial of the form qix plus cix plus di. Fine. Here we are taking qix equal to cix plus di, the linear case we discussed in the previous lecture and here also. So while discussing the qi of x, if we are taking qi of x equal to x power 2 plus cix plus di, then it is called the quadratic interpolation function. If you are taking qis like this one, it is called the linear interpolation function. So as I mentioned earlier, here we are taking the coefficient of x square as 1 particularly, but in general form of the quadratic polynomial is we can get some constant k x power 2 plus cix plus di, we can write as ki, whereas here if Li of x and Fi of x satisfying these two condition, that means the endpoint condition, based on this endpoint condition we obtained these parameters. Fine. Here the qi influence on the function fi, not on li. Now instead of this linear, if one can choose this quadratic function, then what will happen in the with respect to the initial condition, what will happen? The initial conditions are fi of x1 and y1 equal to yi, and fi of xn and yn equal to yi plus 1. In the sense, if you are choosing the quadratic polynomial of the form this one, the second one, this is the, I can call it as first one, this is called it as second one. Fine. Now the f of x of the general form we consider as fi of x comma y can be written as alpha I time y plus qi of x. If we choose this linear form, we obtain the coefficient a to a, b, c, d. Now if we are choosing this one, what will happen? In the quadratic form, if this one if we are choosing, then this equation becomes fi of x1 comma y1 can be written as yi. This x1 y1, if you are choosing this form, then this one, the left hand side equal to alpha I time y1 plus, here instead of x we need to replace x1. So x1 square plus ci x plus di, which is equal to yi. If you are using this endpoint condition, fi of xn and yn equal to yi plus 1, then one can get alpha I of yn plus xn power 2 plus ci, this is x1, xn plus di equal to yi plus 1. Now you can see from this two equation, the factor, this factor, the scaling factor alpha I is a predefined parameter that we need to choose from -1 to +1, whereas this is a predefined parameter we need to choose. This alpha is, if we fixed, then the remaining constants are ci, di for this equation, and here ci and di, because x1 y1 x1 xn, here also x1 xn and yi plus 1 will be given in the data point. For all I belongs to nn, this data point will be given. So now our job is we need to find the only these constants, this constant c, d only. There is no other constant. So we have two equation with two unknown. Therefore this system is consistent system. This has a unique solution. Whereas if you choose this polynomial, quadratic polynomial of this type, then one can get this equation will becomes like, these two equation will becomes like alpha I y1 plus x1 square plus, instead of x1 square we need to write this ki x1 square plus ci x1 plus di equals yi, and this equation becomes alpha I yn plus ki xn power 2 plus ci xn plus di equals yi plus 1. Now here how many unknowns are here? You can observe here ci is unknown, that means the constant value, di is unknown, here the same ci di, and this number alpha I is the predefined parameter that we can choose from this range. Then yi and yi plus 1 will be taken from the data point, whereas this ki, we have one more constant or unknown ki. Now, in the each equation we have 3 unknowns, 3 unknown values. So, we have 2 equation, but 3 unknown. Therefore, this system is inconsistent. So, that while defining the interpolation function, we carefully chosen the quadratic polynomial, the highest degree coefficient as 1. If you are choosing apart from 1, if you are choosing any other polynomial, then it will not work. We cannot find the solution for this system. This system is inconsistent system. We cannot find the solution. Therefore, we are choosing the quadratic polynomial. We are choosing this particular case. Now, let us find the influence of scaling factor on this data point with respect to the linear fractal interpolation function, because we are choosing QIS like this one. Then for the given data set, for this data set, how many data set we have? Totally 6 data set we have. From here to, you can observe x value 0, 0.1, 0.4, 0.6, 0.8 and 1. So, starting from 0, 0.2, 0.4, 0.6, 0.8 and 1. This is the given data point. In the equal interval it is given, fine. Now, we have 1, 2, 3, 4, 5 interval. So, for each interval we need to choose the scaling. So, for each interval I can take first alpha I equal to 0 in all the interval. I can take, because we need to find L1 here, L2, L3, L4, L5 as well as F1, F2, F3, F4, F5. This alpha will acting on the F in the vertical scaling factor in the controlled in vertical direction. Therefore, this alpha we need to implement in the function F, not under L. So, we have the 5 function. So, in each interval we have one function. For each interval we need to choose one alpha. Here alpha I am choosing as 0 in all the interval. Then the second case I am choosing alpha I as 0.2. The third one I am choosing alpha as 0.4 and other one I am choosing alpha I 0.6. That means I have, for if I am choosing alpha I equal to 0, I will get one iterated function system. For that I will get one fractal interpolation function, because Li of x equal to Aix plus Bi. This is for the x direction. In the y direction we have Fi of x comma y equal to alpha I of y plus Cix plus Di. We are choosing as the linear function. For all the I from 1 to 5, I am choosing alpha I equal to 0, then this term becomes 0, only this function will get, we will get one iterated function system when alpha I equal to 0. Similarly, when alpha I equal to 0.2, we will get one more iterated function system. Like that, we will get 1, 2, 3, 4 iterated function system. Each iterated function system will generate a one fractal interpolation function. Let us see what is the resultant fractal interpolation. See, when you are choosing the scaling alpha equal to 0, the data points are given here, then alpha equal to 0, the fractal interpolation function is nothing but line joining these points. Simply the line joining the 2 points, here it is given, you can note. And when you are choosing alpha equal to 0.2 in all the interval, here 0.2, here 0.2, 0.2, 0.2, then we will get this graph. When alpha equal to 0.4, one can get this graph, and alpha is 0.6, one can get this graph. So, for the given set of data points, given set of data points, by choosing the different scaling factor, we can get the different fractal interpolation function which is depicted in this figures. One can observe that whenever alpha I is close to 0, we are getting the smoother approximation, we are getting smooth function, whereas if alpha is approaches to 1, the irregularity is increasing. You can see here and compare A, B, C, D in all the images. When you are choosing alpha 0.5, we are getting more fluctuation than the remaining 3. Also, you can observe if you are taking this part alone, this exactly reflect the whole images. Therefore, this is the self similar flavor of the fractal object. The fractal interpolation function obviously exhibit the self similar flavor. So, here also you can take any interval here and compare with the whole images, it will reflect the whole. This also exhibit the self similar nature and this also exhibit the self similar nature. Here it is a linear curve, it is a Euclidean object, obviously it has a self similar nature, but whereas here what is the difference between these 3 images and here, it is a self similar nature, but not in the sense of fractal sense, that we will discuss it later. Now, in the next example, consider the data point here and choose the scaling factor. In the previous example, in all the interval we have fixed the alpha I values all are equal. Here there are 5 data sets here, therefore 4 interval. In each interval I am choosing different scaling factor. Then you can see, then the corresponding iterated function system is given here. Here Li of x we can take Aix plus Bi, and Fi of x comma y one can take alpha I of y plus Cax plus Di. Here in the constant A, B, C, D are obtained by using the formula which I showed previously, that alpha I values are fixing here. Alpha 1 is minus 1 by 3, alpha 2 is plus 1 by 3, alpha 3 is minus 1 by 2, alpha 4 is 1 by 2. Now, the alphas, as we know, the vertical scaling factor acting on the function f alone, there is no effect on the Li of x. Okay. Then now you can see, if you are choosing alpha 1 as a minus 1 by 3, then you are getting here the minus 1 by 3 is acting on y. Then corresponding C and D values are given here, and here the alpha is acted here and the alpha is applied on y here and alpha is obtaining here, because remaining this qi of x, this function, this one just blind the data between over the given range. Fine. Now, here for the given data, for the given set of for fixing the scaling factor, we are generating this type of iterated function system. Now, the question is, what is the contraction factor of the iterated function system? Because whenever we are speaking about the iterated function system, we need to speak about the iterated function system's contraction factor. Here L1 to L4 are the contraction on I. That means L1 to L4 with respect to I form the contraction iterated function system. First one, we find the contraction factor of L1, because Ln in the form of Aix plus Bi. Li is the contractive homeomorphism. Then we need to find what is the contraction factor. That contraction factor, as we explained before, this Ai will act as a contraction factor and Bi just shifting the interval from left to right. Now, what is the contraction factor of the first mapping? It is 1 by 3, and the second map contraction factor is 1 by 6, and the third map contraction factor is 1 by 4, and this map contraction factor is 1 by 4. Fine. Then this Li together with the set I for I equal to 1, 2, 3, 4 forms the iterated function system. Then what is the contraction factor of this iterated function system? We need to take the maximum among all the contraction, that is called the iterated function system's contraction factor. So, here the maximum of all this number is 1 by 3. So, the contraction factor of this iterated function is 1 by 3. Similarly, this Fi is acting on the contraction on x, where x is the, here x is 0 to 1 cross the minimum value among the y is 1 by 3, 1 by 5 is the minimum and the maximum value is 1 by 2. So, we can take y as a as 1 by safer side 6 and this one as 3 by, maybe we can take 1, not an issue. The a we can take any, b we can take any greater value than the maximum of a value, we can take, maybe we can take 0 comma 1 also without loss of generality, we can take 0 comma 1, fine. Now, here x with this Fi for I equal to 1 to 4 form the iterated function system. Then this iterated function system contraction mapping is minus 1 by 3 for F1 contraction factor is modulus of 1 by 3. So, 1 by plus 1 by 3, not minus 1 by 3. Contraction factor must lies between 0 greater in between 0 and 1. The contraction factor k must lies between 0 and 1. So, it is 1 by 3 and F2 the contraction factor is again 1 by 3. The F3 contraction factor is 1 by 2 and F4 contraction factor is also 1 by 2. So, we need to choose maximum among all, that is 1 by 2, that is the contraction factor of this iterated function system. Now, from this Fi and this Li we are forming the Wi. So, Wi of x comma y is defined as Li of x comma Fi of x comma y. Then we can take x with this Wi again forms the iterated function system. Then what is the contraction factor of this iterated function system, that we need to find. So, for finding this contraction factor, as we already discussed, first we need to find the contraction factor between this Ai and this Ri. So, 1 by 3 and 1 by 3, the maximum is 1 by 3 only. We need to take the maximum is 1 by 3 and compare L2 and F2. Here 1 by 6, here 1 by 3. The maximum is 1 by 3. First we can find maximum of Ai and Ri, where Ri is the contraction factor of F and Ai is the contraction factor of L. First, for finding the contraction factor of each map, each W1, W2, W3, W4, first we need to find the contraction factor of Ai and Ri, then take the maximum, that is called the contraction factor of Wi, which we can call it as Ki maybe. Then what is K1? K1 we can get the maximum among 1 by 3 and 1 by 3 is 1 by 3 and K2 is maximum 1 by 2 and 1 by 3 will get 1 by 3 and K3 is here 1 by 4 and here 1 by 2. So, 1 by 2 is the maximum and here 1 by 4 and 1 by 2, again K4 is 1 by 2. Then after finding 4 contraction mapping of each pair, then you can take the maximum among all this number, which is equal to 1 by 2. Therefore, the contraction mapping of this iterated function system Wi with the space x for I equal to 1, 2, 3, 4 is 1 by 2, the maximum among all this pair. So, this is the contraction factor of this one, then this generate the graph like this one. So, the first with respect to this alpha and this data, this iterated function system generate the fractal interpolation like this one. For the same data set, choose the alpha like this one, 1 by 2, minus 1 by 2, 3 by 4 and 3 by 4. There are small change in the, here taking minus 1 by 3, plus 1 by 3, minus 1 by 2, plus 1 by 2. For the same set of data, if I am choosing alphas 1 by 2, minus 1 by 2 and 3 by 4 and 3 by 4, then f dash is the Fractal interpolation function generated by the following iterated function system for the same set of data, not different set of data, because the data set is fixed. This is the data set, this is the data set we fixed. Now we are changing the vertical scaling factor. Now as vertical scaling factor make the influence on the y direction, alpha y plus cix plus di, therefore there is no change in the L, that means the horizontal direction. Whereas in the vertical direction, one can check the contraction factor is 1 by 2, here 1 by 2, here 3 by 4, here 3 by 4. So if you are finding the maximum, 1 by 2 will get contraction factor of this 2 pair is 1 by 2, this 2 pair is 1 by 2, this 2 pair is 3 by 4, this 2 pair is 3 by 4. Therefore, the contraction mapping associated with this 4 map with Wi is 1 by 4. Therefore, the fractal interpolation function generated by this iterated function system is given here. The data points are same, we are taking the data points are same. For choosing the different set of contraction mapping, we are getting two different interpolation function for the same set of data. So, if in the real life scenario, if the data are more irregular, in the classical interpolation always give the one smooth approximation, whereas by choosing the proper vertical scaling factor, we can approximate the real time data by using the fractal interpolation function. Also you can observe from the figure, it exhibit the more it exhibit the self similar nature at all the scale. Whenever you are zoom in and zoom out, it will give the same structure. Therefore it is a good approximation for the real time data. I will stop it here. Then the next lecture I can discuss the what is the effect of variable scaling on fractal interpolation function. That means we have the vertical scaling factor. In the vertical scaling factor, as of now we have discussed only on the constant scaling factors, whereas if already we discussed, there is a one more option of the vertical scaling factor chosen as a function. If we choose the vertical scaling factor as a function or variable scaling factor, what is the effect of fractal interpolation function, that we will discuss in the next lecture. Thank you.